Morena. I'm going to go through the level 2 calculus paper from 2022 from NCEA. I'm doing it exam style, so if there are mistakes, got it. Okay, a function. Probably going to find the derivative. So if there are mistakes, my apologies, but I'm sure you guys can find them. Find the gradient of the graph of the function at the point where x equals 3. And it's a morning run, so I'm guessing I'm more prone to error. Although the calculus exam is generally pretty straightforward, so I think we should be all good. Yeah. I'm going to use my calculator because these numbers are already looking pretty big. Okay. Yep. For the function f dash of x equals this, the graph of f of x passes through a point, find that. So I'm going to integrate or anti-differentiate first. X minus 3x squared plus 2 over 3x cubed. Yep. Just got to double check I'm doing these things right. Passes through the point. Naughty, naughty. I wonder if that number's going to come out nice. 3 to the power 3 plus c. 4 equals 12 minus 9, 27 plus, that's 27 over 3 is 9. Ooh, yes. Times 2 is 18. Oh yeah, nice number, well done. Unless I'm wrong, which is highly possible, highly likely. So we got 30 minus 27, which is 3, this equals 1. I'm going to write this out again. 4x minus 3x squared plus 2 over 3x cubed plus 1. Use calculus to find the values of x for which the graph of the function yada 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 is decreasing. Let's go for a derivative. And some people might go for a second derivative. 2x squared plus, oh, convenient, minus 20. Let me just double check that. Multiplied by the power, reduce it by 1. Multiplied by the power, reduce it by 1. Sorry, my brain's just a little bit slow at this stage of the day. Ooh. Okay. Negative 40. How do we get there? It's like 8 and a 5. Oh no, plus 8 minus 5. Yep. Yes. 2x squared plus 8x minus, oopsies, minus 5x minus 20. In fact, the moment I said that my brain's going slow, it's slowed down even more. It's like an excuse. I'm doing great. I'm gotta keep it up. X plus 4. 2x minus 5. So you gotta use some algebra skills here. Or you could solve it on your calculator. Okay, so the first one is, I'm going to do it slowly so I don't make a mistake. 2x minus 5 equals 0. 2x equals 5. X equals 5 over 2. And then this one, x equals negative 4. Okay, so let's draw the function. It is a, this is my trick for these, by the way. See, the highest power is 3, and it's a positive. So it's a positive cubic. I'm just going to draw a positive cubic, and those 2 points happen at x equals -4, the lowest one first, and then x equals 5/2. And they want to know when it's decreasing. We can see that it's decreasing here. So it's decreasing from -4 less than x less than 5/2, function decreasing. The tangent to the curve blah blah at the point 2, -10 has a gradient of -6. Okay, I'm sure we have to find the derivative. It's probably worth an achieve mark to find this derivative here. P minus 2qx. Yep. And we know at that point it has the gradient of that. So we can use this information and this information. -6 equals P minus 2q2. And then there should be another simultaneous equation we can set up. We know that that's a point in the function, so I'm just going to give myself a little bit of space so I can see it's a separate thing. -10 is equal to P times 2 minus Q times 2 squared. Yep, and then let's just tidy that up a little bit. 2P minus 4Q. I'm going to make P the subject of both of these. Sorry about moving my equal sign. 4Q minus 6. And then on this one, I'm going to do the same thing and move the equal sign a little bit as well. 4Q minus 10. And then I'm going to halve everything. 2Q minus 5 equals P. Nice. Same subject. 2Q minus 5 is equal to 4Q minus 6. I'm going to drag their Q's onto the right so it stays positive. Then I have to bring that over here. Q equals a half. Which one looks easier to play with? This one here. 2 times a half minus 5 equals P. 1 minus 5 equals P. -4 equals P. Oopsies, I got the camera for you. I should check that, but nah, I really don't mind if I get these wrong, to be honest. The excellent ones I should probably check. A new business is designing a logo based on a stylized H shape. That's a stylized H. This one sort of has it. As seen in the diagrams, the logo is to be designed with 2 semicircles and 2 straight lines. The owner of the new business wants to include space for the company's name inside the shape, so he has asked the designer to maximize the area inside the shape. The owner plans to build a replica of the logo, and due to material constraints, the total perimeter of the shape must not be greater than 80 centimeters. Find the maximum area. Use calculus to show that this is a maximum. Nice. I like it. So really, it's just, I think we need to add in an lowercase h, because that's quite important. Let's set up the perimeter one first. So this is just perimeter is equal to 2h low key the circumference of a circle plus 2 pi r, because it's, you've got your 2 lines and then you've got your top of your circle and your bottom of your circle, and so it is just the perimeter of one circle, and then you just got those 2 lines there. So that's it for perimeter. And we know that that must not be greater than 80 centimeters, less than or equal to 80. But I'm probably just going to change that to an equals, because it doesn't need to be discrete or anything. Okay, let's find out the area. So the area is just a big old rectangle with HH 2R, but then it minuses out a circle from that. Yeah, this is pretty. It's nice and straightforward. So area turns out to be, I'm going to just call it 2RH minus pi r squared. Yeah, that's it. Okay, what I'm going to do is I'm going to just, I don't need to rearrange this, so it's going to be an H on it in terms of H. And then we can play around with it. I didn't give myself very good space, to be honest. I'm going to go 2h plus 2 pi r equals 80. And then I'm going to make it 2h equals 80 minus 2 pi r. I'm not allowed to use this space, guys. How beautiful do these look, by the way? Wow. And then h equals 40 minus pi r. So the reason I'm doing that is so I can get rid of the h variable in here and get another r variable involved. Therefore I can call this the area in terms of only r. So then I've got 2r 40 minus pi r minus pi r squared. Then let's expand that. Again, these equal signs going diagonal, I don't like doing that, but yeah, I've let you guys down. 2 pi r squared minus pi r squared. Ooh, why do I keep writing a of r? I don't need to do that. 80r minus 3 pi r squared. It's just a parabola? It's surely a cubic. No, it's just a parabola. It's a negative parabola, and you're going to have your maximum up here. So then we've just got to differentiate. A dash of r equals 80 minus 6 pi r. Set that equals 0. Throw that 6 pi r over here. R is equal to 40 over 3 pi. I mean, it says find, oh yeah, we need to find that area now. A of 40 over 3 pi is equal to 2, oh no, I like this one better. I'm going to use that. I'm going to make this into an 8. 80 times 40 over 3 pi minus 2 pi 40 over 3 pi squared minus, oopsies, I'm off the page. I'm just using this into here, minus pi 40 over 3 pi, but where am I? Here. Oh man, I could just use that one. Oopsies. And you go away from me. Yep. Okay. 80 bracket 40 over 3 pi minus 3 pi Alright, let me just yep. 2 why for some reason my brain's not happy about this movement. Z that's a number, and that's a number. If I was doing pi r squared minus... Ugh, dang it, I shouldn't have done this in the morning. 40 over 3. I'm going to come back and check this one at the end, but I can't. Yeah, it's a negative area, guys. Can't be right, because I get 2r times h and then I minus off pi r squared from it. Yeah, that makes sense. This here, the perimeter gets me to there, 2h equals that minus that. Yep, I'm happy with that. 40r, 80r. Negative 2 pi minus pi. Is this squared functioning how I want it to function? Is that what squares look like on these new calculators? Yeah, looks about right. I mean, it can't be a negative area that I'm finding here. But I guess this being squared makes it big. So I may have done something wrong. I got the derivative. Yeah. Put it equal to 0. Bring that over. It's 80 over 6. Oh, the pi's at the bottom. Yep, there we go. My bad. Mistake. Pi's at the bottom. Pi down here. Pi down here. And I can fix it. You go down there. You go down. Oh. Yeah. There we go. Oh, 69. Hey, can I fit it in here? Yes. 169.765. And what are we in? It's an area and it's in centimeters. cm squared. Use calculus methods to show that this is a maximum. I mean, is that maximum enough? Is that enough proof to you guys? I think it is. 40 over 3 pi. I mean, just in case, we're going to do an a double dash of r. We'll just get the second derivative, but I wouldn't normally do this. Equals negative 6 pi, and that is less than 0. Whatever r is, local max. Well, it's not whatever r is, but it's, yeah, whatever this value is. Fine, let's write the thing. 40 over 3 pi is a local max. Okay, moving on. The gradient graph of a function is shown below. Okay, negative cubic. Let's get a possible graph of the original function. Ooh, the gradient graph of a function is shown below. Ooh, nice. Negative x to the power 4. So we're looking at one of these bad boys. 1, 2, 3, 4. Yes. So we want to get one of them on there. And we need, so the turning points of it are decided by the intersections here. Let's see if we can take them down the page. We want to have this one nice and high. So let's go like here. This one, we want to have it dropping a bit. Let's go to like here. Yep. And then this one. Oh, am I keeping it up? It's on for there. Okay, so it's further over. What do I want it to do? I'm going to just plan that one later on around it. Yeah, let's go for it. I'm losing my curvature. I'm not used to using these pens. That has to stop there. Oh shucks, this is ugly, guys. This is ugly. Yeah, I'm not a fan of my work here. That is ugly as heck. Am I happy with that? No. That is horrendous. Oh well, what are you going to do about it? A cricket match is being played. A cricketer hits the ball and its height h above the grass cricket pitch in meters can be modelled by this function. Where t is the time in seconds since the ball was hit. Let's draw up negative parabola. Boo! So find the maximum height above the ground that the ball reaches. H dash equals 22.5 minus 9.8 t. 0 equals that. Let's bang this over here. Then we've got a number that belongs to my calculator and not to my brain. Oopsies, does that matter? Nah. T equals 2.296. And then what are we in? Blah, 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 blah. Oh, maximum height. That's a time. So we need to go h at t equals 2.926. H equals 22.5, 2.926 minus 4.9. Am I going to run a space? 2.926 squared plus 1. There you go. 22.5 926 minus 4.9 2.926 squared. That new squared button, A, plus 1 is big. 24.884, and what are we in? Meters. Damn. Nice. I could put it in there, but I don't think they care. This question. During the cricket match, spectators both come and leave the venue. The number of spectators can be modelled by this equation between 0 and 7.5 hours. Number of spectators, hours since the start. And that shows that the rate of change of spectators is this many people going away at that time. B dash equals 200t minus 8t to the power 3 plus 750. No, that goes away. Dang it, turned off my brain. I gotta double check if I was doing stuff wrong. When t equals 6. The rate of change is 206 minus 8, 6 to the power 3. Is that doing your headable? 36, nah, 216 times 8, no, it's 2, no, not me, not keen. 8 times 6 to the power 3, negative 528 spectators. What is the meaning of this value for the rate of change? The negative, camera space, the negative is people, what do they say, what's the word, leaving, it's people leaving the venue. What is the meaning of this value for the rate of change? To me, it means, I don't know if this is entirely true, but I'm pretty sure. So this is a negative quintic. It's one of these. It means between when t equals 6, means that this from here to here, from 5.5 to 6.5, this graph dropped. Oopsies, I wasn't even drawing that thing. This graph dropped 528. So how to put that into words? I don't know if this is entirely true, but I'm pretty sure this is how it works. Between the time of 5.5 and 6.5 hours from, did it say the start? The start, 528 people left. The function, oopsies, dropped by 528. That's fine, whatever. In another match, the number of spectators is modeled by something different, but it is also a negative quintic. They love in this graph. Not quintic, have I been saying that? Quartic. The k is a constant. Find the number of spectators is growing fastest when t equals 4. So one of the, oh no. When we differentiate it, then this is a negative, so that's a cubic. So when we differentiate it, the number of spectators is growing fastest when t equals 4. So we're either looking at this point here, or what else could we be looking at? Growing fastest. Or it could be like somewhere in here, couldn't it? But this is, no matter, well, whatever the cutoff is, when t equals 0, it'll be like, that one could also be the highest point. So it'll be one of them. But we know it's when t equals 4. So it's probably going to be over a bit. Okay, let's derive, find the derivative, equals 2kt minus 8t to the power of 3. And we know that when this is 0, one of the solutions is 4. But there's 3 solutions. because there's those 3. Oh, we don't actually care about that. What are those telling us about? We don't care about the maximum amount of people. We care about this change happening here. So this doesn't actually matter, but we could find those points. It's going fastest when t equals 4. So that's a point of inflection. What if we do the next derivative? What does it look like? Equals 2k minus 24t squared. Actually, I can just set that equal to 0. I feel like this is low-key cheating though, because you may not have learnt this. And then does that happen at t equals 4? If so, that's too easy for times 4 squared equals k. But yeah, 12 times 16. I'm not doing that in my head right now. I should though. Is that true? I'll check. Oh. It's going fastest. I could draw my calculator, but what method would you do? Oh, you would probably, yeah, maybe it's between these points. So let's see what the solutions for this are. 8t cubed equals 2kt. 4t can I just, so t equals 0 is one solution to that, so the line's actually here. Squared equals 2k. Yeah, just because I know one solution would be 0 equals 2t k minus 4t squared. So this shows us that t equals 0 is a solution. So I think that happens at t equals 0. So this one's actually wrong. This is p, and this is t. Okay, and then let's see if we can find the other ones. Did I do something wrong here? That's not meant to be there, right? 4t squared equals k. The times are k over 4, t equals root k over 4, the plus or minus of that. So that's where the other ones happen. Oh, look at this. We can just test that and see. Oh, they seem a bit big. No, that could be alright. So we'll go square root of 192. Oh, yeah, nice. Over 4. 4 root 3. Ugh, no, not good. Because because it's meant to be t equals 4. Oopsies, I've done something wrong. What did I do? Oh no, but that's been the, so this is the other turning points actually. No, this could be right. So, but that can't be a negative. Oh, unless t equals 0 is the middle one. Yeah, whoopsies. So this is the I've done it again now. And then this one is actually negative 4 root 3. And this happens at, what is 4 root 3? Oh yeah. 4 think, let's do our updated graph. I think the graph looks like this. The t equals 0 is here. I don't know where that happens, but I think this is our graph, and this happens at negative 6.9, and this happens at 6.9. This is at 0, and then this fastest growth period is at t equals 4, which I think makes sense, but low-key I want that 4 to be in the middle of those 2 points. Is that right? I'm going to have a look at the graph now that I've found my supposed k, and this could be wrong. 192 variable squared. Wow, these new calculators, guys. Wow. Minus 2x to the power 4 plus 750. Let's draw that. Get that view window. No, what do you do for these days? How do you get this menu up? We want to look from negative 6.9 to like 10, and I don't know, like negative 1. How many visitors? I don't even know. Oh, more than what I guessed. Wow, these guys are popular as heck. Oh man, this is classic guess and check. I probably should have just typed it in. Okay. It does seem to look pretty good. Let's input like a 4 here. We'll see if that happens at that point of inflection. Y equals 4? No, I want to make that a type x equals 4. Yeah. Then we'll get rid of this one. Yeah, that seems to happen at the point of inflection. No, yeah, but it's not halfway. Yep, looks pretty good to me. What was the question? Find the value of k. I have to explain my reasoning clearly. Second derivative. Find the point of inflection. I just don't know if I got that right. Because then, so I start with this. It becomes a negative cubic, and then that becomes a negative parabola, where this describes that point, this describes that point, and this describes that point, and then this describes that point, and this describes that point. So this max is when the most spectators, this is the max spectator increase, and that happens here at t equals 4 on where the parabola crosses over. I'm pretty sure it's right. I should probably make that match up to here. That's enough explaining. Anyway, that could be wrong. Who knows? Not me. Taking too long though. Oh. Find the equation of the tangent of the curve. Bleh. Let's expand that. Y equals 2x squared minus 6x. Y dash equals 4x minus 6. Tangent x equals 1. Gradient equals 4, 1 minus 6 equals negative 2. We've got a gradient. Now, x equals 1, let's sub that into the original. Y equals 2 1 squared minus 6, 1. 2 minus 6 is negative 4. So we've got an x value, we've got a y value, 1, negative 4, and we've got an m value. So y minus negative 4 equals, how am I going to make that into a 2? Negative 2 x minus 1. Y equals negative 2x. That becomes plus 2 plus 6. No. Because that's plus 4. It becomes minus 4. Oh shucks, I should have done it slowly. I'm going to do it slowly. Plus 2, and then that's plus minus 4. Oh my goodness, that's so ugly, and I've used the marker's space. They're going to be pissed. 2x minus 2. Oh, that could be wrong. That's messy. On the diagrams below, show the graphs for the functions this function, this function, and this function. On the axis below, sketch the graphs of their respective. I hear that lots of students are asking what this word meant. It just means you match up the one above it and below. You don't even really need to read the questions. The graphs of their respective gradients. So this is a, what's the gradient? M equals negative 1. So that's y equals negative x. So the derivative is going to be negative 1. Nice. This is positive x, positive 1. I probably should have checked the axes to see if it is actually that. Yep. And this is a parabola. This is like the parabola of parabolas. Cross 1 up, 1, cross 1 up. No, cross 2 up. Oh no, it's not. Cross 1 up, a half. Across 2 up 2. So this is like a x squared over 2, because you go across 1, you square 1 and then half it. Square 2 is 4. Oh, is this? Oh no, whoopsies. I didn't check the scale properly, my bad. I go across 1, I go up 1. I go across 2, I go up 4. This is a traditional parabola, x squared. Y dash equals 2x. I'm getting a phone call. Let me just check if it's important. Oh, my car's ready at the panel beater. Yeah, boy. 2x. That means 2x. I go across 1, up. Oh, whoa! They didn't give you a scale up here. Interesting. I'm gonna make that a 2. I think I have to do that for all of them. Oh, I did these wrong. These should be, I'm going to label it. I'm going to call this 1, 2, 3. Low-key, if you're doing this in the exam, see how 4 squares is 2. So I should really be going up 4 here. So these ones could be on this line. And this one could be on this line if you were doing the exam and you looked at the scale. I'm going to call this one 2, which is confusing as heck for the marker, but no one's marking it. So I'm going to make that my 2. So it's going up 2x. So it goes across and up 2. Across 2, up 4. So I need to draw a line going through there. Ping, pang. I'll do. That curve's annoying. Oh, the diagram below shows the graph of the function y equals px. This is y equals the absolute value of x. This is a normal straight line going there, but when it goes into negatives, the negatives become positive. On the axis below, sketch the graph. What's another way to think about that? Y equals the positive square root of x squared. On the axis below, sketch the graph of the gradient function. Y equals p of x. This one is decreasing. and this one it's increasing. So this, let's split the graph in two. This is just y equals x, and then this is just y equals negative x, isn't it? y1 and y2. I'm just splitting it, cutting it down here. So this one's decreasing. Oh, I did the same thing. This one's always increasing. And then that point there, what is it doing? That point there, it's just leave it like that. Is it true to say that the gradient of the function is 0 when it... Oh man, that's a banger. Yeah, nice. Is it true to say that the gradient of the function px is 0 when x equals 0? Okay, I'm going to make sure I label this as 1 and this one is negative 1. Is it true to say the gradient of the function is 0 when x equals 0? I don't think it's true. It's either negative 1 or 1. Is it true to say the gradient of the function p of x is 0 and x equals 0? What is the function doing? The function is decreasing from this side, but it's increasing from this side. And then it hits this like limbo zone. The fact that they've put... Why did they put a circle on there? Have they done that on any of the other graphs they presented us? Okay, that's just their way of saying that's the origin. So that's not... Sometimes if you drew it like this and you had a circle there and then you did it like that, you could say that there is no gradient. So it's definitely not 0 and x equals 0. Yeah, it's either increasing or it's decreasing. From the left it's decreasing, and from the right it's increasing. That's sort of bad language. Neither have a point of inflection, no, a turning point. Well, it sort of is. Is that a turning point? If you considered it as a turning point, which I don't think it is, then the gradient would be 0. I'm not confident about this one, but that's sort of my line of thinking. It's It's either the decreasing one or the increasing one, and it's not. There's no point where it's like, yes, I am 0, unless you sort of pretended that was a turning point, but it's not. That's as much as I'm going to say about that. A calculus class is exploring 3D geometrical art. Yeah, boy, I want to be in that class. The students decide that they want to create wireframe models of a tetrahedron and an octahedron similar to those shown below. Man, if my students wanted to do this, I would be keen to help them out. Where A represents the length of each edge of the tetrahedron, where B represents the length of each edge of the octahedron. Is that the same as that? Yeah, they would set that to be the case. I'm just going to draw that in there. They will make each edge with a piece of wire and join each piece together, then cover each surface with paper to create lanterns similar to those below. They wish to create each model so that the total resulting surface area of the two shapes is a minimum. Have they got limited wire? Oh, they do. They have a total of 180 centimeters of wire. Minimum surface area SA, and we want to minimize surface area. Okay, so which is equal to square root 3a squared plus 2 square root 3b squared. We want to minimize that. Okay, so we need, and I know that, how many things are there? 1, 2, 3, 4, 5, 6. Count it again. 1, 2, 3, 4, 5, 6. 6a is the wire. This one here, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 12b wire. So the wire is equal to 6a plus 12b, and that is equal to 180. I'm going to go set A as the 6a plus 12b equals 180. 6a equals 180 minus 12b. A equals 30 minus 2b. So SA in terms of B, which we want to minimize, is root 3 bracket 30 minus 2b bracket squared plus 2 root 3b squared, which is ugly. Do it sort of slowly. 900 minus 60, 120 plus 4b squared plus, and then that's not anything exciting, 900 root 3, nothing, oh no, I can't see anything there, minus 120 root 3b plus 4 root 3b squared plus 2 root 3b squared. I wonder if these numbers are nice. And then there's 6 of these packages. And that's surface area in terms of B. And the shape of this is a parabola, so our min's going to look like that. Ooh, it's definitely not going to be nice to solve. What if I times everything by root 3? I'm going to times everything by root 3. Just because I want to get rid of that stuff. So it's 2700 minus 360b plus 18b squared. And then can I divide everything by 18? Yeah. Yeah. Nice. 0 equals b squared minus 20b plus 150. I'm feeling it. No. Kiss. 150. How do you get there? And then with a 20. What's like 50 and 3? Let's mess around with that some more. 10 and 15. We want to get to negative 20. It's going to have to be two negatives. But why? Oh yeah. Two negatives that add 20. 5 and 15? 75. Are they ugly? It's been pretty so far, so I would expect this to be nice. 1, negative 20, 150. No real roots. What have I done wrong? Let's try the original one. 6 root 3 negative 120 root 3 and 900 root 3. No real roots. I've made a mistake. Oh, I'm a numpty, guys. This is, I can't, no, it's all wrong. I didn't do the derivative. I'm doing a calculus paper and didn't do the derivative. SA dash of B. Yeah, I was wondering why there was going to be two answers. This was equals, oh yeah, this gets rid of all the crap. Nice. Plus 12 root 3b. And then 0 equals all that. And then this, I'm going to send that over. 120 root 3 equals 12 root 3b. And then 10 equals b. Yeah, it makes sense. What are you trying to find? To minimize the totals, the lengths of the edges. So b is 10. Where's a nice A formula here? A equals 30 minus 2 times 10 equals 10 itself. Really? 60 plus 120 is 180. To justify the surface area as a minimum, the minimum of that is a positive parabola, and that happens at b equals 10. Have I justified that, or they want me to do the second derivative? Let's just do the second derivative just to justify it. S A double dash B equals 12 root 3, and then so SA double dash of 10 equals 12 root 3, therefore local min. Well, it's just the min actually, don't even need to be local. Okay, and that's it. That took me quite a while actually. It took me an hour for the calculus one. There you go. Alright, GG.